Welcome to our today's class. I remain your friend Sir Galagash, and I want to take you through this graph. This is a graph of functions, and we are looking at calculus and its notations. So there are different kind of graph that we have seen in computations and maybe in derivatives of different functions, as you can see. So the first type of graph that we have here shows a complete oscillations. So it is a graph given by y as a function which is equals to sine of x. Y as a function giving a sine of x. And this takes you back to the introduction video that I did earlier on in terms of how to understand and interpret different sign symbols on the space, and even using a little graph sketch or illustrations. So from here we have the amplitude, which can be given as lambda in terms of calculation, and then we have the period shift. This period is simply telling you how far the graph can go. So we have amplitude, which shows a kind of linearity, because this is a straight line and it shows us a one complete oscillations. Here in y-axis, of course, we are referring to y as a sine of x. We can see that this side shows the displacement, and then we have distance. There is a difference between displacement and distance, and that takes you back to the concept in physics when we talk about waves as a form of disturbance. So wave is a form of disturbance that transfer energy from one place to another, knowing that energy can neither be created nor destroyed. And that takes you also to the laws of conservation of energy. We know that energy can neither be created nor destroyed. It can only be transferred or transformed from one form to another. And the device that we use in changing or converting energy from one form to another is called transducer. It is called transducer. So this is the first type of graph, and we shall be looking at different kind of graph that will help us to understand that how we can apply this same graph in computations. So let's look at the following graph. So we have the fundamental circles graph. Of course, you can see this gray line. This is the first line showing that the function y is equals to cosine of x. Remember, when we had a complete oscillation, the graph is showing sine of x. In this case, it is a cosine because we have two kind of graph. Of course, the rate and this is interchanged, and we are able to understand that this graph does not start from the origin. It starts from coordinate 0, 1 and 0, -1. So you are able to use these pi notations in order to represent this graph, and able to maybe find the derivative of the functions in case if it is given. So this would be the second type of graph that we will talk about today. So we have the third graph. We have the third graph here. So this third graph is what we call the polar graph. This is a polar kind of graph. Of course, it is spiral because it gives you an idea of how a spring looks like. So in this case, we see a graph who starts from the origin and it goes in this manner, which is, you can say it is moving in a circular manner, but this is a spiral graph. known as polar graph. It is a standard graph system that we use in calculus. Of course, the radius of this graph is given as theta, where infinity shape, where r squared is given as a cosine of 2 theta, and a must be less than 0. And we are going to explore more how we can use this graph in order to solve other computations. Here we have negative root a, and this side is root a. So you can as well take coordinates like 0, 1 or 1, 0, and then we can have negative 1, 0, depending on the type of computations that we will be using. This infinity, which we call the lemniscate, in terms of our graph system. The third type of graph is what we call the four-leaf rules. The four-leaf rules. Of course, the four-leaf rules shows you a kind of infinity. This is a sign of infinity, and this is another sign of infinity being joined together on the Cartesian plane. So we call it four-leaf rules because we have 1 through 3, 4 of them, and this graph simply represents r, which is equals to a cosine of 2 theta, where a is greater than 0, and we shall see how to use this graph in computation. And then we have a compressed circle, and this graph is the Lamission. Lamission is a French word. So we have the Lamission, which gives you a compressed kind of graph, and this Lamission is taking you through r as a minus b cosine of theta, where a is greater than b and b is also greater than 0, depending on the computation that we are going to see later on in this video. Of course, here we have a plus b. We know from the concept of Cartesian plane that this is positive, that this is negative. But when we look at the Lamission and see how things are changing, we are going to factor out the negative so that we have positive and interchange the negative on this side so that we have a plus b and a minus b in this side. This is x-axis, y-axis, and we'll see how this graph can be used in computations. We have earlier on looked at this graph. So we have a cardioid. A cardioid, like the heart. It shows you it is a kind of apple sign. A cardioid. So a cardioid is a function and a graph that shows that r is equal to a 1 into cosine of theta, where a is greater than 0, and it is good you know all this kind of graph. This is more advanced mathematics for those who intend to pursue their masters in mathematics and even especially in pure math, and also those who are doing international standard edition for international Cambridge examinations. It is good you pay attention, even though some of this concept is more advanced to year 12 and year 13 and year 14, but some of them is required in year 12 examinations. But ideally, it is best for you to know what to expect in each of these functions as we explore them together. So we have looked at this, the four rules graph, and we shall look at more graphs in the subsequent videos. Follow us for more.